let's moving on to a cyclic ethers. We have a 3-membered ring, 4, 5, and 6. All right. Tell me real quick, any of these, which one is the most reactive? Should be the oxide ring system, 3-membered ring. Ring strain, high torsional strain, so this guy totally. Okay. All right, so we're gonna focus on, because of the reactivity, we're gonna focus on the oxide ring system, or we call this guy an epoxide, 3-membered ring ether. All right, a little bit of common name so we can communicate. So the all-time common name, this guy we call ethylene oxide because it's made of an alkene named ethylene. Propylene oxide is made of propylene. That's why it's called ethylene oxide, propylene oxide, right? Adding MCPBA, which is peroxy benzoic acid, or acidic peroxy acetic acid. So convert alkene to the epoxide. Okay, so we just call it after the where ethylene where it's made of, basically. But well, we don't really use it. We call it right here. So this is an IUPAC name or systematic name. Method 1. We look at the epoxy group, epoxide as a substituent called epoxy, right? This is an epoxy group. The parent chain, just like an alkane and alkyne. So those are the main, the parent chain, all right? So in this case, I'm going to count real quick. So 1, 2, 3, 4, 5. We got methyl at 3, the epoxy group at 2 and 3, and this pentane, okay? All right, start with 3 right here. So we got 3 methyl, 2, 3, yep, both of them, 2 and 3, epoxy. And then the parent chain is pentane, right? So notice that both location of the epoxy group are included. Okay, that's the rule. So that's how they do it. This one, all right, find the parent chain first. So we go, let's say go to the right, from the right side. 1, 2, 3, 4, 5, 6, 7. Is it heptane? Ethyl at position 3. The epoxy group at 3 and 4. All right, start with ethyl. Got 3 ethyl, 3, 4 epoxy, right? And then heptane. Okay. All right, that's the first one. Now, oh, we're not done yet. So we have a stereo center here. So don't forget to count. So we go, what do we do here? 1, 2, and 3. Okay, so oxygen here, number 1 for sure. You guys know that. Carbon with 3 more carbon, so that's number 2. Carbon with 1 more carbon, number 3. Hydrogen is at the back, so we go 1, 2, and 3. This is R. There we go. All right, that's a method 1. So we look at the epoxy group as a substituent. Method 2, the epoxy group is actually the parent chain. We call oxide ring. This is an oxide ring system. Okay, that's all. And we call anything else on it, those are substituent, right? So we have ethyl, methyl, and methyl. Now we have to indicate where these guys are. So we have to count the position, add the position. So oxygen is number 1, 2 right here, and 3 on the left side. We don't do the other way around because if you do right here, the ethyl and methyl are going to be on position 3. On this one, ethyl and methyl on position 2, right? So we got 2 and 2. This is 3 and 3. Of course, we take 2 and 2. The lowest number. So we got 2 ethyl, 2, 3 dimethyl. Don't forget di there. And this epoxide, which is the parent chain, we call them oxide ring. Okay, because that's an oxide ring system. All right, next one we have oxide ring here. 1, 2, and 3. We got 2 ethyl, the diethyl. Don't forget di. 2, 2 diethyl, and then propyl at position 3. So 3 propyl, oxide ring. This guy also have the stereochemistry, the chiral center here. So this is R. We did together before. So we just put R here. All right. Yep, that's it. That's how we read it. I read the name. Okay. All right, the epoxides or oxide ring in nature. So we have seen in sex pheromone of some type of moth, sex pheromone of cockroaches. Okay. We also have a medicine. So this compound we have epothelone A and B are found and extracted from a certain type of bacteria in southern Africa, and this but this guy have a anti-tumor effect, so they inhibit tumor, and because of this activity, it leads to this compound anti-tumor agent, right? FDA approved in 2006. So isabepilone. I don't know how to say it. So this we used to inhibit to treat breast cancer. Okay. All right, so epoxide. Yep. All right, preparation of epoxide.